So what is probability? Probability is measuring how likely an event will occur. What this means is that how much are you sure, or how much quantity that you can give to your sureness that this particular event is going to happen. So that is what is probability. It is the ratio of the desired outcomes by the total outcomes, right? So with that particular formula, you will be able to understand what is the probability. It is the desired outcomes by the total outcomes. So always remember that probabilities always come up to 1. So if you have 0.6, that means you have a 60% probability that this particular thing will happen. If you have 0.6 of something happening and 0.4 of something not happening, they always sum up to 1. Remember, probabilities always sum up to 1. So some examples that I've given over here are rolling a dice. There are 6 possibilities, right? So every possibility has one outcome out of the 6 outcomes. So for example, the probability of getting a number 2 is 1 by 6. So that is the probability of getting a number 2. This is basically what is probability. So what are the terminologies that you need to understand when it comes to probability? There are 3 things, okay? You need to understand what is a random experiment, what is a sample space, and what are the events. Let's understand all of these terminologies one by one now. So what is a random experiment? It is an experiment or a process for which the outcome cannot be predicted with certainty. So for example, if I give you a dice, okay, and I tell you to roll it and tell me the number that you're going to get it. You are not sure because that's a random experiment. You have this uncertainty whether this particular event will happen or not, okay? So that process where you roll a dice and all of that, that is a random experiment. So what is the sample space? The entire possible set of outcomes of a random experiment is the sample space of that experiment. It's really simple, right? I tell you to roll a dice, there are 6 outcomes. So it can be either 1, 2, 3, 4, 5, 6. That particular range of 1, 2, 3, 4, 5, 6 is the sample space. It is all the possible outcomes for the random experiment that you've been doing. Simple enough. So what is an event? An event is one or more outcomes of the experiment. So if I told you, roll the dice, you get a number 1, that is an event. You roll the dice again, you get a number 6, that is an event. So what outcome you get from your random experiment is called the event. There are 2 types of events. There are joint events and disjoint events. Let's understand both of these. So joint events have common outcomes, right? Joint events can be together. That is what is a joint event. For example, you have a student who can get 100 marks in statistics and 100 marks in probability. The outcome of a ball that can be delivered can be a no ball also, and it can be a 6 also. And it can be possible are called joint events. Disjoint events do not have common outcomes. So the outcome of a ball that is to be delivered cannot be a 6 and a hit wicket or something like that, okay? So a single card cannot be a king and a queen together, and a man cannot be alive and dead at the same time. So those are disjoint events. Those are not at all possible to happen. Now that we've understood all the types of events, we need to understand the distributions. So now we have 3 distributions that come under probability. We have the probability density function, we have the normal distribution, and central limit theorem. So let's understand all of these distributions one by one. So the first one is PDF, probability distribution function. So the probability now can be described using an equation. The equation that describes a continuous probability distribution is called the probability density function. I hope it's very clear to you. If it is not, let me just simplify it even more. You have a function which is going to describe the probability of something happening in the form of a graph. It's that simple enough to understand. You have a function which will give you the probability which you can plot a graph on. So that is the reason it is a continuous probability distribution. Okay. As you can see here, you have A and B. Between the range of A and B is the most likely that something is going to happen. So now that you've understood what a PDF is, let's understand the properties of the PDF. The graph of the PDF will always be continuous. It's simple enough to understand that. Then the area bounded by the curve of the density function and the x-axis is always going to be 1. And the probability that a random variable assumes a value between A and B is equal to the area under the PDF bounded by A and B. What this means is basically if you have any particular value or any particular probability that is between A and B, it is going to be equal to the area that is bounded by A and B, the probability value. So that is basically what a probability density function is. So next we have the normal distribution. So what is a normal distribution? It is a probability distribution that associates the normal random variable x with a cumulative probability. So how do you find this particular divided by 2 sigma 2, where x is the normal random variable that we have just taken up, then mu is the mean and sigma is the standard deviation. And this is how the normal distribution looks like. The graph of the normal distribution depends on basically two factors, which is the mean and the standard deviation. So the mean determines the location of the center of the graph and the standard deviation determines the height of the graph. So if you have a very big deviation between, your variables, it becomes a very short graph and very wide graph. Whereas if you have a good deviation, which is, very less, you will have a tall graph. That is basically what's going to happen over here. That is all we have from normal distribution. Then the central limit theorem. So this is basically a theorem which is stating that the probability is always going to be in the center of the graph. Let me tell you the statement of this. The central limit theorem states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. So what this basically means is that the distribution of your mean or your samples are always going to be near the center or always going to be near the mean of your graph if your size is large enough. So what this basically means is that the distribution of your mean or your samples are always going to be near the center or always going to be near the mean of your graph if your sample size is much large enough. So what this means is that if your sample size is very big, it is going to be a normal distribution. It is as simple as that. So as you can see, if I have n is equal to 1 component, you can see the graph. As it increases to 3, as it increases to 10, as it increases to 50. So as you can see, it almost becomes nearly identical to a normal distribution. So that is what the central limit theorem is. So once we are done with that, we will look at the types of probability. We have marginal probability, joint probability, and conditional probability. Let's understand each of this. So what is marginal probability? Marginal probability is the probability of occurrence of a single event. If I flip a coin, it is going to be either a head or a tail. That occurrence of that single event is called as a marginal probability. So for example, I have a deck of cards here and I randomly take out a card from there and I want it to be a heart card, right? So that will be the probability, which is 13 by 2, and it can be expressed by this particular formula. So once we are done with marginal probability, let's go to joint probability. What is joint probability? It is the measure of two events happening at the same time. So the same example over here, I have a deck of cards out of which I want to take out the ace, which is a hearts. So it has to be a ace card and it has to be a heart card, which will be the probability giving me 1 by 52. So now that we've understood what is joint probability, let's understand what is conditional probability. So the probability that depends on something already happened is called as the conditional probability. It is basically the outcome of the event is based on the occurrence of a previous event or an outcome. Conditional probability of an event B is the probability that an event will occur given that A event has already occurred. What are the two types of formula that we have in conditional probability? If A and B are dependent events, then the expression for the conditional probability is given by P of B by A is equal to P of A and B divided by P of A. If A and B are independent events, that means the expression will be P of B only. So it is just the probability of B occurring. Whereas if they are dependent events, means that if you want to find the probability of B, A already has to be occurred. So it is a probability of A and B divided by the probability of A. So that is basically all the introduction that was required from probability. We now have Bayes' theorem. So what is Bayes' theorem? It shows the relationship of one conditional probability and its inverse. What is Bayes' theorem? It shows the relation between one conditional probability and its inverse. So this is the formula, that is P of A by B is equal to P of B by A into P of A divided by the P of B. So what does this particular thing mean? So what we are trying to find out is the probability of the occurrence of A given that B has already occurred is equal to the probability of B occurring when A is already there and the P of A, which is the prior probability, which is something that we already think of. and then the probability of B occurring. So this is basically what the Bayes theorem is. Let me give you an example for it, okay? Suppose you're a doctor and you're running a clinic where you test if a patient has a liver problem or not. All the previous patients that had come to you, out of them, 10% of your patients had liver problems, okay? So all the patients that had come before, they had around 15% probability that they were drinking. So now we have found out the probability of A and probability of B, the prior probability and the probability of B. So what was the probability that out of all of those patients, even though they had a liver problem, they were drinking? It is 5%, which is P of A by B. Hence, the Bayes theorem says that the probability that a new patient, whoever is entering, will have a particular liver disease is calculated by 0.05 into 0.10 divided by 0.15 is equal to 3.33%. What this means is that if a new patient is going into the clinic, there is a chance of 3.33% that that particular person is also having a liver problem. This is basically how the Bayes theorem works. So what are the applications of probability? Probability helps you to optimize your model. Classification of our algorithms also requires probability. The loss can also be calculated using a probability. Then models are built on probability. So we go to naive Bayes. This is the naive Bayes classifier. So let me tell you what I have done over here. I have imported the data sets, the metrics, and all the required naive Bayes classifier, and I've imported the Gaussian naive Bayes classifier. The Gaussian is also another name for the normal distribution. Okay, so normal distributions are also called as the Gaussian naive Bayes classifiers. And why I have done this is because I had visualized it and I came to know that it was a normal distribution. Okay, so I load the iris, that is the load iris dataset, and I load a model, and then I'm just going to fit the model. Okay, then I'm going to get the predicted model of it, and then I'm just going to basically find all the metrics of it. So basically, let me show it to you. What is the precision, recall of all of that? So this is all the accuracy. Then my model has an accuracy of 96%, and this is the confusion matrix, which means that out of 50 it was able to classify all the 50 correctly. Then out of 50 it classified 47 correctly and 3 were wrong. And then out of 50 again over here, 3 were classified wrong and 47 were classified correct. So this is the naive Bayes classifier. So as you can see, probability is actually being used in all of this. The Gaussian naive Bayes classifier already does all of that. So we do not need to, worry about it much more. Statistics. What is statistics? Statistics is an area of applied mathematics concerned with data collection, analysis, interpretation, and presentation. What this means is that you are going to analyze, understand all the data that you've collected and how you're going to present it. So for example, your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? What are you going to do? You are basically going to collect a large amount of people around. You're going to take all of those people. You're going to, give them basically the new drug that you have created, and then you're going to interpret all the results that you get from it, and then you're going to present that out of, let's say, 1,000 people, around 900 of them were cured or 950 were cured. So all of those parts come under statistics. Okay. So I hope you've understood that. What are the terminologies that you need to understand when you work with statistics? There is population and there is sample. So what is population? It is the collection or a set of individuals or objects whose properties are to be analyzed. All the data that you have collected is called as the population. So out of all the data that you've collected, you take out a set of data for your analysis. That set of data is called a sample. So what is a sample? A subset of the population is called as a sample. So a well-chosen sample will contain most of the information about the population parameter. So how do you choose the sample? The sample needs to be chosen such that all the data that the population is trying to convey can be conveyed through the sample itself. So that is what is population and sample. Now that we've understood the basic terminologies, let's look at some of the sampling techniques that we have in statistics. So sampling can be classified as probabilistic and non-probabilistic type of approaches. So in probabilistic sampling, we have random sampling, systematic sampling, and stratified sampling. In non-probabilistic one, we have snowball, quota, judgment, convenience, and all of that. Okay. So, but for machine learning, we do not need to take a look at the non-probabilistic approach. We just need the probabilistic approach. So we will be now covering about random sampling, systematic sampling, and stratified sampling. So let's go ahead with that. So what is random sampling? You take out a sample randomly out of the population. That is basically what is random sampling. Each member of the population has an equal chance of being selected in the sample. So that is what is random sampling. So what is systematic sampling? Systematic sampling is basically you follow a particular order out of which how the sample has to be taken. As you can see here, I have 6 particular groups. Now from this 6 particular groups, I'm going to take all the even ones, right? So that'll be 2, 4, and 6. That is basically how the systematic sampling works. I follow a system. I follow an order of how I'm going to take the sample. So once we are done with that, what is stratified sampling? What is a stratum, first of all? A stratum is basically a subset of the population that shares at least one common characteristic, which is the gender, which I have taken over here. So as you can see here, I have the whole population, out of which I have found out one property that is common between all of them. That is gender. They are either male or female. So I'm going to break the whole population based on that. I'm going to break my population into the male subset and the female subset. So after that, I'm going to apply the random sampling and I am going to take out all the samples that I am going to be needing. Okay. So once I have now broken down my particular subsets, now I'm just going to be using random sampling and take out all the samples that are required by me. So this is what is stratified sampling. So what are the types of statistics that we need to infer from? We have descriptive statistics and inferential statistics. So let's understand each of these right now. Okay. So what is descriptive statistics? Descriptive statistics is mainly used to focus upon the main characteristics of the data. It provides the graphical summary of the data. So as you can see over there, descriptive statistics uses the data to provide descriptions of the population, either through numbers or calculations or graphs or tables. Okay. So as you can see here, I have my shirt and there can be either 3 particular sizes. There can be the most minimum one, the most average one, and the most maximum one. And all of that is based on the weight of the person. Suppose, for example, if a person weighs 60, he's going to get the maximum one. If the person weighs 40, he's going to get the average one. The person weighs 20, he's going to get the minimum one. So that is how I am describing my data and I'm going to infer data from it. So that is descriptive statistics. So what is inferential statistics? Inferential statistics makes inferences and predictions about a population based on the sample that is being taken from it. So what this means is basically I'm going to generalize a large data set and apply probability and draw a conclusion to it. So it allows me to, infer data parameters based on the statistical models which is using the sample data. I have a whole bunch of population out of which they can tell me they have either the large size or the medium size or the small size. So according to their sizes, I'm going to supply them the t-shirts. So this is basically what are the 2 types of statistics. There are descriptive statistics and inferential statistics. Descriptive statistics, what does it do? It describes the data. Whereas inferential statistics takes information from the data and then analyzes accordingly to however we want it to. So these are the 2 types of statistics. Let's go in depth with descriptive statistics. What is descriptive statistics? It is used to describe and understand the features of a specific set of data. So what is descriptive statistics? It is a method used to describe and understand the features of a specific data set by giving short summaries about the samples and measures of the data. In descriptive statistics, it is broken down into the measures of center and the measures of variability. So what does measures of center have? Measures of center has the mean, median, and the mode, whereas the measures of center have the range, interquartile range, variance, and standard deviation. So for example, here you can see that I have a data set of a car which contains the variables, the car, the mileage, the cylinder type, the displacement, the horsepower, and the real axle ratio. So I'm going to find out the mean. So what is a mean? Mean is the average of all the samples. So for example, if I want to find the mean of the horsepower, I'm going to just add the values and divide it by the number of values. So I get 103.625. This is the mean of the horsepower. So what is the median? It is the measure of the central value of the sample set. That is what is a median. So let me show you how to find it for the miles per gallon. To find the order of the center value, you have to basically arrange it in the ascending order. Okay. So you have 21, 21, 21.3, 22.8, 23, and accordingly. Now I have to take the two middle values. Okay. So that will be 22.8 plus 23 divided by 2. That becomes 22.9. So that is the median of my sample. Next, let's move over to mode. The value which is most recurrent in the sample set is called as the mode. So let me find the mode for the cylinder type. What is most recurring, the 6-stroke or the 4-stroke? I can see here that there are 1, 2, 3, 4, 5. So there are 5 times that the cylinders type of 6-stroke has been repeated, and 3 times cylinder type 4-stroke has been repeated. So 6 becomes the mode of the data. Okay. So now that we have understood all that is required from measures of center, let's move over to the measures of spread. So a measure of spread is also called as a measure of dispersion, is used to describe the variability in the sample or the population. Okay. So the first one is a range. Range is the given measure of how spread apart the values are in a data set. So it is the maximum value minus the minimum value, which gives us the range. So what is an interquartile range? Quartiles tell us about the spread of the data by breaking the data into many quarters, just like the median breaks itself. So for example, if I have 8 datas over here, I can break it down into 3 quarters, where I have a 1, 2, then I have 3, 4, 5, 6, and 7, 8, which become different samples accordingly. Okay. How do I find what is the interquartile range? So how will I find the interquartile range of this? Okay. So the first quartile Q1 comes between the 25th and the 26th. So it'll be 45 plus 45 divided by 2. That becomes 45. The second one comes under 50 and 51st. And that will be 58 plus 59 by 2. That will be 58.5. And the next one comes at 75 and 76. That is 71 plus 71 divided by 2, which is always 71. So that is basically what is an interquartile range. It is the measure of variability based on the dividing set into the quartiles. So that is basically how you break down the interquartile range, and it is the measure of variability based on dividing the set into quartiles. So quartiles divide a rank ordered data set into 4 equal parts, which would be Q1, Q2, and Q3 respectively. And the interquartile range is measured by Q3 minus Q1. So if you can see this, you have the whole data, which is 100%, and you have broken down the data into 25% each. So the quartiles come in between the first Q1, Q2, and Q3. So those are the interquartile ranges. So now that we've understood that, let's move over to variance. So variance describes how much a random variable differs from its expected value. It entails the computing squares of the deviations. So that is how you find the variance, which is S square is equal to the summation of 1 to n is equal to 1, xi minus x bar, the whole square divided by n. So xi is the value and x bar is the mean. I hope that's simple for you to understand. What does a variance mean? It means the difference between the data which it should have actually been. So what does the variance actually try to tell you? Okay. It basically means that the data which should have been something and what it really is, what is the difference between them, how much it differs from each other. So that is what is the variance. So what is a standard deviation? Deviation is the difference between each element from the mean. So I have xi and I have the mean. What is the difference between each of them is the deviation. So what is the population variance? The population variance is given by this particular formula, that is sigma square is equal to 1 by n. The whole summation of I is equal to 1 to n is equal to xi minus mu the whole square. Once we have found out the population variance, what is the sample variance? So it is S square is equal to 1 divided by n minus 1, the summation of I equal to 1 to n, and xi minus x bar the whole square. That is the sample variance. So what is the standard deviation? Standard deviation is the measure of the dispersion of a set of data from its mean. What the standard deviation is trying to tell you is basically that how much this data is trying to disperse from its actual data. So how is that given by? It is given by 1 divided by n. summation of I equal to 1 to n xi minus mu the whole square, which is basically the variance's square root. So that is standard deviation. So how do you find the standard deviation? I'm just going to give you an example over here. So say for example, Daenerys has 20 dragons and they have the numbers accordingly. So how do you work out the standard deviation? So the mean is given by adding all the numbers, dividing it by 20. So mu is equal to 7. And then what is the standard deviation? So it'll be xi minus mu the whole square. So it'll be 9 minus 7 the whole square is equal to 2 square is equal to 4. Then you have 2 minus 7, all accordingly. You keep on going and you get the following results, which is 4, 25, 4, 9, 25, 0 accordingly. Once you have done that, put that into the formula. So you have this formula accordingly. So we get the variance square is equal to 8.99 and the standard deviation will just be the square root of 8.9, which will be 2.983. What this means is that with a value of 2.983, the values are differing from the mean. So if you are trying to add 2.983 to all the other values, you will be getting something which is much more similar and much more realistic and much more, closer to the mean of the. So that is how standard deviation works. Now that we've understood all of that, we have a very classic example of information gain. So what does information gain help us with? This is an ideology that comes into picture for decision trees. So let's understand the basic concepts of what we require in information gain. So the first topic that we need to understand is entropy. So what is entropy? Entropy measures the impurity or uncertainty that is present in a data, and it is given by the formula h of s is equal to minus summation of minus 1 to the power of n p of I log base 2 p of I, where s is all the instances in the data set, n is the number of the distinct class values, and p of I is the event probability. Because entropy is the impurity that a data has. So what is information gain? Information gain is how much information a particular feature will give to the final outcome. So that is given by gain of A of s is equal to h of s, which is the entropy, minus summation of j is equal to 1 to v, s of j divided by j into h of s of j is equal to h of s minus h of a by s. H of s is the entropy of the whole data set. S of j is the number of instances with j and a value of attribute a. S is the total number of data sets. V is the distinct value of attribute a. H is the entropy of the data set with value a and entropy of attribute a. So these are all the requirements. So let me see the data set over here, which is for 14 days and the particular, attributes that are given to it. So the forecast is to find out whether the match will be played or not according to the weather conditions. So this is what we are trying to find. Here we have 5 no's and 9 yeses. So we have the outlook and then we have sunny, overcast and rainy. So in sunny, we have 3 no's and 2 yeses. In overcast, we have 4 yeses and 0 no's. And in rainy, we have 3 yes and 2 no's. So how are we going to find out which particular node is going to, attribute the most to it? So let's find out the entropy first for the whole data, which is 9 instances say yes and 5 instances say no. So we have minus 9 by 14 log base 2 of 9 by 14 minus 5 by 14 log 2 of 5 by 14 is equal to 0.940. So what this means is that the data that we have has 0.940 times bad data. Means it cannot give us much information. There is much more impurity in the data. So let's move over. The first step in information gain is to find the root variable. So how are we going to find the root variable? We are going to take all of the attributes and find the information gain from them. We have outlook, we have windy, humidity, and temperature. So let's find out the information gain. So for information gain of windy, we have 6 instances true and 8 instances false, right? So h of s is equal to 0.940 minus 8 into 14, and as you can see, all the other variables. So the gain that we have achieved from windy is 0.048, which is really, really less. So for outlook, the same thing happens over here. We have the information gain that is being passed by it is 0.247. Then we have the information gain from humidity that is 0.15, which is also really good. And then we have temperature, which is 0.029. You can pause and look at the steps if you want to. Out of all the gains that we have, the variable with the highest information gain is used to split the data. So Outlook has 0.247, Windy has 0.048, gain has 0.151, and gain of temperature is equal to 0.029. So what are we going to choose? We are going to choose Outlook. Why is that? It's because it has the highest information gain. So that becomes our root node. That is a simple example of how statistics is used in the information gain. Next, let's move over to the confusion matrix. So what is a confusion matrix? Confusion matrix is a table that is often used to describe the performance of a classification model. So it is a table that is used to describe the performance of a classification model on the set of test data. So how are you going to calculate the accuracy of this? It will be true positives plus true negatives divided by true positive, true negative, false negatives. So if you are confused with what is true positive, true negative, false positives, false negatives, let me explain that to you right now. Let's say, for example, there are two possible predictor classes which are yes or no. The classifier made a total of 165 predictions. That means 165 predictions were total. So out of the 165 cases, the classifier predicted yes 110 times and no 55 times. So in reality, 105 patients only had the disease and 60 patients did not. So how are we going to put this into the table? So as you can see here in the table, we have n is equal to 165. Then we have predicted no and predicted yes, actual no and actual yes. So if our classifier predicted it no and it was actually no, that is the correct output. If it predicted yes and it was actually yes, that is also the correct output. But it predicted it as yes and it was actually no. That means it has made a mistake. And it predicted no, but it was actually yes, it has still made a mistake. What are the correct values over here? Which is 50 and 100. So 50 and 100 are the correct values and 10 and 5 are the wrong values. What is a true positive? True positive are which it was predicted as yes and they actually have the disease. True negatives are predicted no and they did not have the disease. False positives are classifier predicted it as yes but they did not have the disease, and false negatives we predicted no but they also had the disease. So this is basically what a confusion matrix is, and it is helpful in finding out the performance of the classifier that you are working with. So that is what is a confusion matrix. Next comes inferential statistics. It is a method where we infer and understand what the data is trying to communicate with us. So it is broken down into 2 points. It is point estimation and interval estimation. So let's understand about point estimation. Point estimation is concerned with the use of a sample data to measure a single value which serves as an approximate value or the best estimate of an unknown population parameter. So you have such a huge population of India, right? Out of that, you're just going to randomly take out some sample of it. You're going to find out the sample mean, and this sample should be so good enough that it is going to estimate the whole mean of the population. So this is how you use point estimation and try to approximate it for the whole, population. So what are the different methods? We have methods of movement, methods of likelihood, Bayes estimator, and best unbiased estimators. So estimates are found out by equating the first k sample movements to the corresponding k population movements, which is the method of movements. And then we have the maximum of likelihood, which uses a model to maximize a likelihood function. Bayes estimator minimizes the average risk, and it is an expectation of all the random variables. And then we have the best unbiased estimators, which is used to find out the best depending parameter. So that is all that we require from point estimation. Let's move over to interval estimates. So an interval or a range of values is used to estimate the population parameters. So we have a point estimate and we have an interval which gives us the low confidence and the high confidence limit. How is this going to happen? There are three things that you need to remember. There is something called as the confidence interval, and it is the measure of your confidence that the interval estimate contains the population mean mu. So statisticians use a confidence interval to describe the amount of uncertainty associated with a sample. Technically, a range of values are so constructed that it is specified probability of including the true value of a parameter within it. So for example, let's take a sample where we have 10,000. So let's say that we have something called as a supermarket. So out in that supermarket, we have collected a lot of data. And in that data, I'm saying that this particular items, okay? So item one and item two, if they both are kept together, they are going to be sold together. And I say that with 90% confidence. So that 90% confidence, okay, is what is my confidence interval. It can be in between this range. It can be between 90 to 95%. And between 90 to 95%, it is highly likely that that particular thing is going to happen. So that is my confidence interval. So what is the sampling error? It is the difference between the point estimate and the actual population parameter, which is the sampling error. Okay. So when mu is estimated, the sampling error is mu minus x bar. It is mean minus the point. What is the margin of error? So for a given level of confidence, it is the greatest possible distance between the point estimate and the value of the parameter it is estimating. What this basically means is that it is the greatest possible distance between what you have predicted and what it actually is, and what level of confidence you are giving to it. Okay, so that is the margin of error. How much error you can allow for the predicted model is what is the margin of error. So I hope you have understood that. So the level of confidence is the probability that the interval estimate contains the population parameter. So as you can see here, all the parameters that come under C, right, are what we are allowing. Okay, that is the margin of error that is allowed. But whatever comes in minus ZC and plus ZC, we are not going to take that. Those are the interval estimates. So finding these intervals is what is our probability. So finding these interval estimates is what is our work over here. Okay. So for example, if the level of confidence is 90%, this means that you are 90% confident that the interval contains the population mean. 0.05 and 0.05 of minus ZC and plus ZC is equal to plus 1.645 and minus 1.645. Those are the Z scores. Anything minus or plus of 1.645 is not allowed. So those are the values that we are concerned with when we are working with interval estimates. So now that we have understood everything we needed to from inferential statistics and descriptive statistics, let's move over to hypothesis testing. So what is a hypothesis first of all? It is some event that you have made up which may have the probability of happening or not happening. Testing that hypothesis is what is hypothesis testing. Is, formally checking whether this hypothesis is accepted or rejected. So how is the hypothesis testing conducted? You first state the hypothesis, and then you formulate an analysis plan of how you are going to, test this particular hypothesis. Then you get all the output. You analyze the data that you've got from all of it. So then you understand whether this particular hypothesis has failed or it is a good hypothesis. Okay. Suppose I have 4 boys over here, which are Nick, John, Bob, and Harry. So they were caught doing mischief in the class and they have to now serve detention for almost 2 months. Okay. The detention is basically they have to clean the classrooms. So John over here comes up with an idea saying that I'm going to write all the names of ours into chits and then put them into a bowl. Whoever name comes out has to clean the classroom. So what happens here that we are going to assume that the event is free of bias. So our hypothesis is, what is the probability of John not cheating? Let's find out what happens actually. The probability of John not being picked up for a day is 3/4. Now the probability just keeps increasing on and on if he is not picked up for 3 days. Okay, so it is 3/4 into 3/4 into 3/4 is equal to 0.42 approximately. And what is the probability of John not being picked up for 12 days? It is 3/4 into 12 is equal to 0.032, which is equal to 3.2%, which is less than 0.05, which is 5%. So what this means is that our hypothesis was that John is not cheating. But actually John is cheating over here because it has come down and it has come below the threshold value of 5%, which is 3.2%. So now all of us have come to know that John is cheating because he has not even written his name in the chits. So this is how the hypothesis works. So what is the null hypothesis? Is the hypothesis that we have created in the beginning, okay? That John was not cheating. That was a null hypothesis. It has no result which is different from the assumption. and we have an alternate hypothesis, which means that our results disapprove the assumption. We had a hypothesis that John is not cheating, but actually through our results, we found out that John is cheating. So this is what is the hypothesis testing. And we have a threshold value. If the probability that we are testing goes below this threshold value, it means that the particular hypothesis has failed. So this is what is the hypothesis testing. So now we need to know something about the P and T values. Okay. What is the P and T values? The P value and the T value help us in our hypothesis testing. Okay. We want to find the height of students who are greater than 5 feet and 7 inches. Okay. So we take a sample of 100 students and find that the mean height was 5 feet and 9 inches. Okay. We make a hypothesis that out of all the 100 students, there is going to be at least 6 students who are greater than 5 feet and 9 inches. So this is our P value. It is the probability value that we are saying that this particular hypothesis is going to be correct. We say that at least out of 100 times, 6 students will at least have a height which is greater than 5 feet and 9 inches. Okay. So this is the P value. This is the probability value that we have given to a hypothesis. The T value is testing this particular hypothesis and finding the difference that we have found out from our assumption and what we have actually calculated from our results. So this is how the P value and the T value help in making the null and alternate hypothesis. You find the result of the null hypothesis and the alternate hypothesis. So this is how the P and the T values help in making and observing the results from the null and alternate hypothesis. So let me go back to the presentation mode. I have my data over here, which is this particular data. So I'm going to import statistics as S, and I'm going to just find the mean median mode of it. So let me just run this program for now. So as you can see here, the mean is 33.43 and the median is 3 and the mode is 2. 2 has been repeated the most number of times, so that is the reason it is the mode. And the variance is 5124 and the standard deviation is 73. That is how the mean median mode is calculated. Let me run the program now so that you can understand what we are trying to do. So let me close this out. What's happening over here is I have the iris data, which is the load iris, and then I am creating it into a data frame. Okay, simple enough. After that, I am saying that the species is the target and the data of species is equal to, I am going to just apply all the lambda parts of it. Okay, and then I am going to get the description of the data. And after that, what I'm going to do is I'm going to take this data and I'm going to pair plot it. And then I'm going to show the plot to you. So let me run the program. Let me show you the figure first. So I had 4 features over here, right? So that was the petal length, petal width, sepal length, and sepal width. So if you can take a look at this data, you can see that there is a normal distribution here. There's a normal distribution here. Also, there's a normal distribution over here with some exclusions over here. And there is a normal distribution here too, but with some exclusions here. So looking at this, I will be able to understand if I want to, apply the Gaussian naive-Bayes classifier or accordingly to however I wanted to. So this is how statistics has helped me to understand what is my data looking like. Now let me go back over here. So as you can see, this is the count of a 150, right? Simple enough. Then what is the mean? What is the standard deviation? What is the maximum length and maximum width that you can find over here? All of this is done using the describe part of it. Okay. And describe is a function that is already available in pandas. So that was a very simple example of how I was able to understand how I have to use the Gaussian naive-Bayes classifier for my iris data, which I showed in the probability part, right? Now we are done with this.